Hello, everyone. Welcome to Session 3, Performance Analysis with RETScreen Expert at the RETScreen World Conference. RETScreen's Performance Analysis Module enables users to leverage this data to gain insights into their facility's energy usage and track the progress of energy-saving initiatives. Starting us off, Sabrina Lachapelle will present automated high-resolution data analysis using RETScreen Connect. Next, Andrew Hejnar discusses how RETScreen has been used for ISO 50001 and SEP implementation at 3M facilities. In closing, Energy at Work's Scott Rouse, Amir Kamandlooie, and Edward Newton will present on measurement and verification for energy management with RETScreen. They will go over the Energy Management Action Plan that Energy at Work developed for 4711 Yonge Street and how RETScreen supported that plan. But first, we turn to Sabrina for automated high-resolution data analysis using RETScreen Connect.
Hi, thank you for joining my session. This session will cover the high-resolution data analysis using RETScreen Connect. So by the end of this session, you will know more about a different type of connection from your data to RETScreen, as well as many ways that you can analyze those high-resolution data. So for the past year, we have added some capacities into RETScreen that allows you to connect your data automatically into RETScreen. So I will show you the different types of connector that we have into the software. So if I click here on RETScreen Connect, you will see a list of different connections that we have. So the ones here at the top represent external data source, such as OLE database, SQL servers, or MySQL. And here at the bottom, we have different types of connection with data monitoring system. So we can connect your data through EcoStruxure Power Monitoring Expert, which is a platform from Schneider Electric. We have here EnergyCap. We have Energy Plus that is managed by the National Renewable Energy Laboratory. We have Hydro Energy Monitor from Hydro Green Solution Incorporated. And finally, we have a Meter Connects from QuadLogic Meters Canada. All of these connections allow RETScreen to automatically import the data from those different systems. The only thing that we would be asking you would be some secure link to make sure that only you can import those data. So you can make sure that your data stay confidential, as nobody else but you will be able to download those data. Those data can be downloaded on a monthly basis, for example, like you are probably analyzing with your utility data, but you can also import those data on a higher resolution form. So if you are looking here at my screen, you can see that I have in my table data that are for each 15 minutes. So if your platform gathers your data on a 15-minute basis, you can now analyze those data. It could also be 30 minutes basis, 1 hour basis, but it could also be less than 15 minutes, of course. We can import several types of data that your platform gathers. So in this case, you can see that we are working with the meter reading for our electricity, as well as the power, but any other type of data that your system is gathering and that you would like to analyze, it will be possible to import into RETScreen. So here we can see that I have my first electricity consumption data for 1st of January 2018. And if I go at my last page. Here we can see that I have data until the end of July 2021. So another thing that we have in RETScreen now is the possibility to import the weather data from NASA on an hourly basis. So you are probably already aware that you can work with NASA data that are on a daily basis, but with our new sub-daily capabilities, we've also added the daily NASA data. It means that you can use all of these weather data in order to analyze your sub-daily consumption or any other metric that you would be working with. So now that we have all our data imported into RETScreen, it's time to make some analysis on them, of course. So if I'm coming here into my Analytics tab, we can see that I already have several types of analysis made. So we can find these here. So most of them, you are probably already comfortable with them. We have annual bar graph, quarterly and monthly bar graph, bar and pie chart, and we can also make the time series. But with those graphs that were already existing into the software, we also added 2 new time series. So the first one is a time series that will allow you to analyze your data on a weekly basis. And the other one will allow you to analyze your data on a daily basis. We also have a new heat map as well as a duration curve. So the first thing that you may want to do with your data is start by a really simple analysis. So you could decide that you want to analyze your data on an annual basis just to see the progression for each year here. So we can see that, of course, 2021 is a partial year, which is mentioned by my legend here. So first information that we see is just the progression of our electricity consumption in our building. But now, since we're working with some daily data, we probably want to make some analysis on those data. So the first one that we have here is the time series on a weekly basis. So instead of seeing the data from the start of 2018 until now, you can see 1 week at a time in order to see more detail in your analysis. So the first thing that we can see is that I'm analyzing here my electricity consumption from Monday to Sunday. You could analyze any other type of data that you downloaded with your metering system. So it could also be power, for example, but in this case, we'll be looking at electricity consumption. So we can see if I put my mouse that we can see the data for each hour. So for this analysis, we've decided to group the data on an hourly basis to be able to make a comparison with the weather data that we also have on a hourly basis, but you could have decided to analyze on a 15-minute basis, since this is how your data are available. So we can see that, for example, here around 6 a.m., our electricity consumption is going up, and then it's going down around 5. So since it's a Monday, we can assume that our systems are turned on for the workday. We can also see here that we have a peak that I will be explaining a little bit later. So now we have our Monday, Tuesday, and Wednesday. And then we are coming to Thursday. So we may be wondering what is happening. Why is our electricity consumption so low on a weekday? So if you are located in Canada, you probably know that on the 1st of July, it's Canada Day. It means that our office is closed, which can explain here why the consumption is so low. Then comes Friday, the consumption is also low. Maybe one of the reasons could be that there are less people in the office. Maybe some people wanted to have a really long weekend and took the day off. Or maybe there are some other reasons that we will be seeing in a few minutes. And then here we have our weekend. So you are probably noticing that we also have a second data set here that I'm putting my mouse on. So this is the cooling degree days. So we are analyzing the cooling degree days because my week is in the summer, but you could also be looking at heating degree days or just average temperature. So we can see how my cooling degree days evolve compared to my electricity consumption. So one of the things that here you may be noticing is that our cooling degree days are lower here during the Friday and also the Saturday, which could maybe explain why our electricity consumption is also low on the Friday. We also have here an horizontal line that represents the average electricity consumption for that year. So you could compare your data with the average of the week. And then here we have a vertical line that represents the peak, which is the highest electricity consumption for your week, right here. Another thing that I mentioned is that we are seeing sometimes some peaks that seems unexplained because it's happening in the evening. So we are seeing one on Monday, one on Tuesday, and then if we're coming here on the weekend during the Sunday night, we are also seeing one peak. So the reason we have those peaks is that, well, those data first represent the real electricity data from our center in Varennes on the south shore of Montreal. So I know for a fact that we do have 2 ice banks that we are using in summer to help cool the building. And those 2 ice banks have a control system that allows them to refill themselves starting at 9 in the evening up to 4 in the morning. So during the evening and the night, if the level of ice is too low, then they can produce a new ice. So the peaks that we are seeing here is when the ice banks are producing new ice. So now that we've been looking at the weekly electricity consumption, we may want to go into more detail and look at the daily electricity consumption. So if I click here, we can see the daily data for the Monday of the week that we were just looking at. So this really allows us to look at one day and have more information about the specific days. So we could, it's basically a zoom of the weekly graph that we just saw. So we can really clearly see when the systems are turned on for the day and when they are turned off. And here is the peak that I was mentioning for the ice banks. So those 2 time series are new graphs, well, new. We added them about 1 year ago that are really helping you to analyze your high resolution data. But of course, we also decided to make some other graph that could be of interest for the users. So one graph that we've decided to add is a heat map. So if I'm looking at this one here, we are looking at the electricity consumption on a daily basis. So if I put my mouse here, you can see that we are seeing one row for each day of the year. And then if I'm looking at my x-axis, we can see that we have data for each hour. So once again, we decided to group the data by hour, but you could be working with any period that you imported into the data. So this graph is really useful to know when how your electricity consumption in this case varies from hours to hours through the year. So we can see that, for example, here during the winter, my electricity consumption goes up around 5 in the morning until 5 in the evening, which is when we are going at the office. And here we could see, for example, that during the summer, we are not using much electricity during the night. So it's really helpful to have a really good picture of how your electricity is, or any other metric, varies through the years and through the time. You could make a similar analysis using, for example, power, if you are interested in seeing how your power usage throughout the year. So we can see here that we have been grouping our data per week. So if you are not interested in seeing your data on a daily basis, maybe it's too much information for the purpose that you have, you could group the data on a weekly basis as well. So we have many options that allow you to play with the data the way that you want in order to produce the results that you are looking for. And finally, the last graph that we have added is a duration curve. So the duration curve is an analysis that is really interesting when you want, for example, to be looking at the power. So how much power you are using throughout the year in order to make some, for example, measures in order to reduce the peak in your facilities. So in this case, you see that we have put 3 different years of power on the same graph if you want to compare your power usage for each year. But you could also decide, if I'm coming into the last graph here, to look at just 1 year of power. And you see here that we also have the possibilities to add some horizontal line that could represent, in this case, what you consider being the peak in your facilities and intermediate power or base power. So these are the 4 new graphs that we have added to analyze your high resolution data. The last thing that I would like to show you is, if I'm coming into my custom tab here, is that we have added the possibilities to take all of these new graphs and prepare some really nice report that you could show in a kiosk, that you could probably show on a screen in your facilities, for example, or that you can export to PDF and share with colleagues or management, for example. So if I'm looking at this one, we can see that what we've decided to picture here is the electricity consumption for a week that would be the same for 4 different years. So you can see for these 4 years how the electricity consumption varies. So it allows you to make some really interesting comparison. And so this is what ends my session. So during this session, you've learned how you can automatically import data from different metering system or external data source. You've seen how you can analyze your high resolution data, and you've quickly seen that you have the possibility to prepare a customized report that you could show on a kiosk or send to your colleagues. So thank you for watching.
Thank you, Sabrina. Let's now make our way over to Andrew and hear about how RETScreen has been used for ISO 50001 and SEP implementation at 3M facilities.
Hello everyone, my name is Andrew Hejnar and I'm 3M's energy manager. This presentation was put together by my team, so I can't get whole credit for it. And I'm very happy to be here presenting at 2023 RETScreen World Conference on our energy management systems, energy management programs, which RETScreen helped us with very much. Before I start talking about RETScreen and energy, I need to introduce you to my company. 3M's been around for over 118 years. Our purpose is to unlock the power of people, ideas, and science to reimagine what's possible, and our promise is to improve lives while helping solve world's greatest challenges. Everybody knows a few of our products, like Post-it notes or Scotch tape, but the fact is that we make over 55,000 different products in 46 different technologies, and we have over 200 manufacturing sites globally. Our commitment to sustainability is very strong. We focus on 3 areas: science for circular, science for climate, and science for community. My team, energy team, focuses on science for climate, and our sustainability goals in climate and energy area are to improve our energy efficiency index to net sales by 30% by 2025, based on 2015 base year, increase renewable energy to 50% of total electricity use by 2025, reduce our Scope 1 and Scope 2 market-based greenhouse gas emission by at least 50% by 2030, and be carbon neutral by 2050. We also help our customers to reduce their greenhouse gas emissions by 250 million tons of CO2 equivalent through use of our products. We are part of many different organizations. RE100 is one of them, where we committed ourselves to be 100% renewable electricity-wise by 2050. We are also part of Department of Energy Better Buildings low carbon pilot partner, and again, Department of Energy Climate Challenge partner as well. Our strategies for climate and energy goals focus on energy efficiency first, and then renewable energy and greenhouse gas emissions. Energy efficiency is a key. When we can produce our products more efficiently, we need less renewable energy, and of course, we emit less greenhouse gas emissions. And energy efficiency is supported by energy management standards, energy monitoring and reporting. And we also use energy concept or energy efficiency concept in early project design stage. For renewables, we have a couple of choices. Grid and utility, of course, is one of them. So we seek renewable energy, electricity being already available on our grids and by our utilities. We also have our own generation on site, solar generation, that is. We don't have any wind or anything else yet. And for greenhouse gas emissions, we need to reduce fossil fuel dependence, and we can do it through fuel switching. We can use thermal, biofuel, hydrogen, geothermal, solar thermal, renewable electrification, and also we started investigating carbon capture technologies. When we work with energy management systems, our approach is a systematic approach to energy management. And as you can see on the left-hand side of the diagram, the sine wave basically is what companies without systematic approach see, where we have a good performance, everything is under control, but then something happens and we lose control of the energy efficiency programs. So really what we need to do is to move to the right-hand side of the slide, and we work towards the energy efficiency to become a company culture. So basically energy efficiency at the core of the business operations is our goal. And the vehicle to do that is ISO 50001 and Superior Energy Performance Program. And we have right now 56 sites globally certified to ISO 50001. The system is a company level certification based on a standard published by the International Organization for Standardization, ISO. And as you can see, the most of implementations are in North America. RETScreen has been very crucial for us to help us with energy management implementation and also ISO 50001 and Superior Energy Performance implementation standards. Our data sources at 3M are multiple. We use energy data from site energy database. Basically, our sites report energy consumption to this site energy database, and then we use it for our analysis. The outside our company data, if you will, weather data, that's a built-in NASA database in RETScreen. We use it a lot for our analysis as well. Production data is also entered to site energy database set system, and statistical regression model data is coming from RETScreen itself. I'm going to show a few examples of models we use RETScreen to help us with. This is a site natural gas model using multivariable regression analysis. As you can see, the predicted consumption, the model is very good when we apply actual gas consumption over the model. The natural gas, actual gas consumption follows the model very closely. You can also see that our statistical values are very strong, R-square being at 97%. And then we have validation results being passed. So this is a new feature to RETScreen. It's been around for a few years now, not a few years, couple of years maybe. We asked RETScreen to include superior energy performance measurement and verification protocol data or requirements to allow us to see if that measurement and verification protocol is met. And when it's met, we get this pass basically indicator that the model is strong. Site natural gas consumption for one of our sites follows the model as well. There are some savings on natural gas, if you can see from the graph, till about 2018. And then what happened is that we installed combined heat and power units. We're gonna show a QSUM of that in the next slide, where our natural gas consumption increased, and you can see it on the graph as well. But our electricity consumption significantly was reduced, and our total energy consumption was reduced as well. So those are the site QSUM graphs for electricity and natural gas. Again, you see those green arrows pointing where a CHP installation happened. And you can see the electricity QSUM nicely improving while the natural gas QSUM is increasing. We use many relevant variables in our modeling. One of them, for example, here is participation. We use basically this model was created for our mining site in Little Rock, where we crush a rock and then we basically convert that rock to a granule, which we sell to make roofing shingles. So when the rock is stored outside and there is a rain or a very humid day, obviously our energy consumption will increase. So we are able to predict that increase in energy consumption by using this model. Another model we use when we don't have good production data is machine runtime hours. And this model uses basically time of our lines running instead of how much product we produce on these lines. So it's another very good model to have in case you don't have a good production data available. We can also use just total units, widgets, if you will, as a relevant variable. So if we make a product which we sell in pieces in widgets, then this model becomes very valid, and the total unit becomes a relevant variable for us. And then we use RETScreen to help us with different analysis of either energy systems or new projects when we want to implement energy efficiency measure. So this example is for a significant energy use, one of our boiler systems, a regression analysis for that system. And as you can see, we modeled boiler fuel consumption in MMBTUs, and the site uses boiler for space heating and process heating. So that's why heating degree days was used as another relative variable for this analysis. Then we report on total energy consumption, either savings or avoided savings. So this is an example of site savings of total energy consumption. 2015 is our base year, so you can see that both the predicted and actual are the same. Then starting in 2016 all the way to 2022, we see quite significant savings from that site. And then we also can use a final 3M portfolio. So we basically roll up all the sites into a portfolio model, and then we see company-wide how well we are performing when it comes to energy performance and savings. We also use RETScreen, as I mentioned, for different energy efficiency measures. So this is an example of a ventilation project, feasibility analysis for makeup air units. RETScreen's got a very powerful tool to help us to identify different projects and just confirm feasibility for those projects. This one here is for combined heat and power. We have 3 combined heat and power units in Ontario. And if it wasn't for RETScreen and initial feasibility analysis, we would probably not have those units installed. And they really help us with overall energy efficiency picture, as well as they are saving us lots and lots of money. Benefits of normalized performance evaluation, which we do because ISO 50001 and superior energy performance, they basically require us to do this analysis. It's a well-established statistical analysis using multivariable linear regression analysis supported by international measurement and verification protocol. It aligns very well with ISO 50001 and superior energy performance, as it accounts for all excuse me, routinely changing relative variables like outside temperature, production, that affect energy consumption. Reporting in percentage of performance makes it better aligned with our corporate targets. And we don't need to use a common production unit. Sometimes, in the past, for example, we were converting our production to pounds, and we were using energy per pound output, which wasn't very accurate in many cases. Now we don't need to use specific units to facilities. We can use gallons, we can use square meters, you can use widget numbers, and of those production units can be used in RETScreen analysis for normalized performance evaluation. And then good product production, good product data can be harvested from SAP system and local systems, and then move to RETScreen. So it makes it a lot easier for us to do this type of analysis. This is my last slide. So if you have any questions, please contact me or my team, and we will be happy to answer any questions you have. Thank you very much.
Thank you, Andrew. Now let's turn our attention to the Energy at Work team and learn about measurement and verification and what happened at 4711 Yonge Street.
Thank you for the invitation to allow us to share our story. I'm going to be talking about our energy management action plan and how we use RETScreen to meet the needs of our clients. So basically, I'm telling you our story. In order to tell our story, I'm going to talk about our overall strategy on using the Energy Management Action Plan that was able to save about 17 million kilowatt hours, which Toronto Hydro was able to verify, and we valued at 3.2 million. But I know you want to know more of the details. And I'm going to turn it over to Edward, who's going to talk about 4711 Yonge Street, which is a commercial building, and what they did specifically as part of their Energy Management Action Plan and how RETScreen supported that plan, as well as an unexpected surprise. This was a utility bill correction that we were able to arrange with the utility, and it was RETScreen that was instrumental in us identifying that opportunity. And then finally, we're going to talk about measurement and verification very briefly. But Efficiency Valuation Organization has worked with RETScreen, or RETScreen's worked with Efficiency Valuation Organization, and together they provided the tools to be able to measure and verify savings, which is critical when you're doing any sort of energy efficiency measure. And Amir is going to be talking about that and sharing it with you. And then finally, I'm just going to wrap up with a few concluding remarks. So next slide. So I want to thank RETScreen for this opportunity. We think RETScreen has been very valuable to the energy management industry as a whole, particularly because they've helped provide clarity to an industry that is quite complicated. When we look at all the variables that you have to deal with, having clarity so that you can talk to not only the stakeholders, your operations and management people, but also the utilities, and have a common language which RETScreen provides is critical. And then the convenience it also provides in getting the key data, particularly weather, doing weather correction, etc., has been very helpful to our team. And I would suggest our energy analysts probably spend 1 to 2 hours a day utilizing RETScreen. And then finally, which is also very important, is to have consistent methodology so that we can take our RETScreen product and share it with anybody else, and they'll get the same result as we do. So consistency is, again, very important. Thank you. So who is Energy at Work and what do we do? Well, we're an energy management company. We're agnostic to any particular product or service. We do a lot of energy audits. We spend a lot of time with existing building commissioning. And we also do a lot of certifications, whether it's BOMA Best or whether it's Energy Star. But our claim to fame is really the Energy Management Action Plan, or we like to call it our EMAP, Energy Map. Our process works, and it works well because it brings management and operations together in order to report, identify, and most importantly, implement. And that's really the action part of the EMAP. We want to bring positive changes, and those positive changes are largely done through operational improvements. We have capital measures and behavioral measures as well, but a lot of the EMAP results came from operational improvements with the BAS, etc. Edward's going to talk more about that. Thank you. So I want to talk about the EMAP, but in a bigger picture. And you can see from the companies on the left-hand side, these are property management companies that we're working with, either one property or in some cases, multiple properties. 28 properties were involved altogether through 12 different organizations. And our role is to prepare an energy management action plan customized for each of those properties. So each property has their own path forward. And that means it has to have its own measurement and verification plan. And that's where RETScreen comes in to help with that. And then we want to identify energy efficiency measures to help achieve the savings or objectives. Sometimes those objectives are tenant comfort, for example. But in order to do that, we need tools that help us communicate. We look back and we're talking with over 100 people per month. And so communication is essential. And again, that's where RETScreen comes in, because it provides that visibility that we need to communicate to the various people and each of the properties. In this case, we worked with Toronto Hydro, which is a utility, probably one of the larger utilities in Ontario. And they service the Greater Toronto area. And what they did is they reviewed our energy management action plan, our measurement and verification plan. They approved it. And then they went on to verify any of the measures that we identified. And those measures received a financial incentive based on the kWh that was saved. In our case, it was over 17 million kilowatt hours, and these savings were verified by Toronto Hydro. The monetary value is about 3.2 million, and this occurred between 2017 to 2020. Thank you. So digging a little bit deeper, you can see the 16 million kilowatt hours from 2017 to 2020. The avoided cost was approximately 17 cents per kilowatt hour. That's what we used. The incentive was 2.5 cents for the incentive. And if you wanted to get some perspective, that's close to 2,000 Ontario homes, the annual electricity use that they would use. And that's based on 8,700 kilowatt hours per home, which is a number we were able to get from the independent electricity system operator. So the table below provides the total kWh. The savings overall was about 7%. And there's the numbers for anybody that's interested in the actual details. Thank you, Edward. So what did we learn? Well, the first thing we learned is that email works. And it works because of the 3 Ps: people, process, and products. People are the most important. They're essential in driving change because they're the ones that make the decision. And it was important that the right person received the right information at the right time. And that's proven very successful for us across all of our clients. Obviously, we need a process. People have to have a framework to know which direction to go in. We call it our EMAP. And then they need the tools, and these we call products. Our toolbox includes RETScreen, and it was probably one of the more practical and useful tools that we use almost every day. So the EMAPs were successful across the 12 property management companies. And what was interesting is that we did have some projects that did not succeed. And I think that is the proof on why it can work when the 3 Ps are united and they work together. So again, that goes to communication, and that's where RETScreen helps by bringing the right information to the right person at the right time. And we're going to get into more details on that. Thank you. So we're going to dig deeper and go to a specific project. And I'm going to ask Edward to share his experience as an energy manager with 4711 Yonge Street's EMAP. Edward, would you like to explain what you did?
Sure. Thanks, Scott. So we'll start by looking at the EMAP objectives that we have for all of our properties. The energy reduction targets or objectives might be different for each building, but we keep the same objectives as an EMAP for all of the buildings we work with. So the first is reducing energy use or utility use. However, it's to do so without compromising any of these 3 things. So safety, tenant comfort, or equipment reliability. We also make sure the EMAP aligns with the objectives of the organization we're working with. So those could be GHG reduction targets or the ESGs, the environmental social governance goals of that organization. And we also work to ensure that the EMAP supports the property management in helping their tenants reach their ESG or GHG reduction targets as well. So when it comes to the actual EMAP, we will meet with the properties on a monthly basis, and it's really cyclical in nature. So we go through these main 5 points, but we're always cycling through it and coming back to it. So the first is analyzing building performance. And I'll speak about each of these in a bit more detail as I go through it once. And then we present findings to operations and management. So what we mean by findings is just a piece of information that we think is worth bringing forward at a meeting. And it's not necessarily a deficiency in the operations or an opportunity for reduction, but something that we think is worth discussing. So it could be something that the building is doing well. It could be a question that we have about the operations, or it could be an actual opportunity. Then we work with operations and management to actually identify what are measures that we can implement without compromising any of those important factors like tenant comfort or equipment reliability. And then we help in the planning and implementation of those measures, and then with the measurement and verification. So what are the tools we use, or the process we use to support this? So when it comes to analyzing building performance, bill and interval data is crucial. So this could be 15-minute interval data or hourly interval data, and we take a deep dive on it for all the utilities on a monthly basis. When it comes to presenting the findings or communicating this information to the client, we find KPIs like energy use intensity, GHG intensity per square foot are important tools, along with data visualization, including heat maps and various graphs. So in terms of identifying the measures, we use BAS analysis, so looking at the actual BAS, looking at the set points and the readings, and we use the Q sums. So we'll typically have a regression for each of the main meters in the building, and using a Q sum, we can identify if there are any changes in consumption patterns. When it comes to the implementation of measures, so we'll do things like trend analysis on the BAS for different points, and then functional tests. When it comes to measurement and verification, it's really a combination of RETScreen and IPMVP. So RETScreen helps in various points in the cycle, and I can dive into those in a bit more detail. So I think it breaks down into three categories. So one is identifying changes in building performance. And these could be data errors, they could be energy efficiency measures, or changes in operations. They help with communicating the impact of EEMs. And then finally, it helps, RETScreen helps with measurement and verification. So we'll take a look at the first point through our case study of 4711 Yonge Street. So this is a building in Toronto, commercial office building, with a very dedicated management and operations team, which is reflected in the numerous awards and certifications that the building receives. It's a high-performing building with an EUI below 20, compared to the BOMA average of 24.7. So we'll take a look at the first point. So we'll do a review of the gas consumption with the Q sum on the point of whether something is an error or an operations issue. So without weather correction, it's really hard to draw conclusions from looking at natural gas data, just because of how tied it is to weather fluctuations. So a Q sum is really helpful for kind of cutting through that noise and helping to identify changes in building consumption that are not purely dependent on the outdoor air temperature. So what we can do is, if we can look at the slope of the Q sum and see if there's a drastic change, either up or down in the Q sum, we know that's something that requires further investigation. So here's a first screen grab of the Q sum of the building. And what we're looking for is just if there's a sudden change in the line. And we can see there's a big jump here, which is in October of 2021. This is the time of the year when the heating season is turning on, but we want to be aware of when something doesn't look quite right. So we see this sudden increase in consumption, and the question comes up, okay, is this an operations issue, or is it something else? Is it a data issue? And so to answer that question, well, here's actually the corrected Q sum with the line flattened out, and here's the corrected consumption that month. So what happened? So it was actually a billing error on the part of the LDC, and it was worth around $17,000. So we saw this sharp jump in consumption, compared the bill data with the RTM data, and brought this to the LDC, who corrected the error and provided a refund to the property. But this issue might not have been caught without RETScreen or the EMAP, because the Q sum is so useful for identifying when something is changed in the building. So what does that mean for the building in terms of this refund? Well, that's 93 tons of equivalent GHG emissions that were the property did not have to report. And there was also a fairly large monetary refund as well. So going to the next point, we use RETScreen to communicate the impact of energy efficiency measures or changes in the building. So a QSUM creates basically a visual of how the building is performing. And when we can plot, when we can add to the graph these different points in time, so different changes in the building, we can see what the impact is. So for example, we've got a lighting retrofit here, and we see a change in the slope of the QSUM there to here after the lighting retrofit is completed, showing an increase in savings. So the difference between the old slope and the new slope would be what the savings are. And we can also show the impact of what lower occupancy can have. So here we have March 2020, the consumption drops right when the building basically emptied out. And we can see what kind of, what the impact of that had on electricity consumption. And if you can accurately and clearly convey the impact of energy efficiency measures or certain changes in the building, I think it helps in bringing more people on board and building momentum. So the third point for measurement and verification, we use RETScreen to quantify the savings for 4711 Yonge Street in the Pay for Performance incentive program. So between 2018 and 2020, the building saved close to 1 million kilowatt hours. And there was a avoided cost and a monetary benefit equaling around $184,000 for that period. So these are very substantial savings. And RETScreen played a very important part in quantifying and verifying those savings. And I'll pass it over to Amir next, who will speak a bit more about the importance of M&V in RETScreen.
Thank you, Edward. Hello, everyone. Thanks for the opportunity that we are given here to share our experience and challenges we had using measure verification. If you go to next slide, yeah. We have been using measure verification in RETScreen as an instrumental tool to deliver results that are defendable. And we wanted to be using it even post-pandemic. But the challenges we had post-2020 made us to think about how better we can use this tool using the changes that is happening. So here's the reference for option C we were using RETScreen prior to pandemic. And then after pandemic, if you go to next slide, Edward, we had that great challenges. Now buildings got empty and their QSUM changed a lot. So we were not able to use whatever the building performance was presenting prior to pandemic as a result of the routinely change in independent variable. So we were fortunate enough that EVO published guidelines for non-routine event and non-routine adjustments. And more fortunate that RETScreen team was very proactive in implementing it. And we had very open dialogue with both organizations. And RETScreen wanted to be first implementer. So they contacted us. They knew that we have some projects underway. So we had 28 projects almost completed under RETScreen, new software, a new version using EVO's guideline that was based on the non-routine adjustment, non-routine events. And we believe that the main reason that RETScreen is very successful in providing a very dependable tool is the visibility. The visibility is something in our complicated world, as Scott mentioned, is needed. And 3 reasons that we believe that RETScreen also provides us in a very good way is supporting 6 principles of measure verification: accuracy, consistency, and the link is provided here. The second benefit was, especially post-pandemic, we had a team of 8 to 10 that they were working on RETScreen across Canada. And we wanted to work on certain projects at the same time. So using RETScreen allowed us to have one file open with 2 different individuals and get the same results. And the third, which is the most important one, was now RETScreen is well established and recognized in the industry. So we were able to work our work and then deliver the file to the third-party verifier or sponsor. So in this case, for 28 buildings, Toronto Hydro had reviewer. So they knew what RETScreen is, and so we were sharing the results so they could see the results, verify it, and go through it, and then document it. So seeing is believing, and so they were able to verify and sponsor the project for the incentives. And finally, thanks to RETScreen team, our experience was published by EVO magazine, in that we shared how we use non-routine adjustment and non-routine event in our project for 4711 Yonge Street. And we were able to get Toronto Hydro's approval as well. So the link is provided for anyone who's interested. The details is in the paper. And Scott, over to you for conclusion.
Yeah, thank you very much, Amir. Edward, thank you very much for explaining that. I can't but look back how much work and effort went into separating the difference between occupancy reduction and energy savings, and really have to give a lot of credit to Amir in being able to make that distinction and work with EVO guidelines, but also RETScreen helping to make it visible and be able to convince Toronto Hydro and eventually the IESO that this is the correct way of verifying the savings. So it was really a terrific project, and special thanks to 4711 staff as well that were very cooperative, and they allowed us to share their story. So RETScreen, measurement and verification plan, they all fit together, and they're instrumental in making our EMAPs a success. And I mentioned that convenience, the consistency, and the be able to constantly improve. What RETScreen has been doing is terrific. We're up to revision 9 now. RETScreen's been a major contributor to bringing our management and operations team together, so that we work as a team, and we've got confidence in going to the next step, but also able to work with our sponsors, both electric and natural gas utilities. As Amir mentioned, Toronto Hydro was a big part of that. And then finally, RETScreen's analytical capabilities, identifying those anomalies. And in that case that Edward shared with that gas error, again, it was not only the economic value, but with the importance of greenhouse gases reduction, it was important that we don't report more gas than what was actually used. So bottom line for us is RETScreen is a powerful energy management tool and something that we rely on and we use every day in our work. Enercan also has some other resources that I thought I'd point out. Existing building commissioning, they've got some really good tools. Also operating a building in response to COVID, they've got this other tool. There's a lot of other tools that Enercan has, so I just wanted to give a shout out. Last slide is really how to contact us if you're interested. We do have a news and views newsletter that's available. You just have to contact through request@energy-efficiency.com. And I want to thank you for the opportunity to share our story. So on behalf of Amir, Edward, and myself, thank you very much from Energy at Work.
Thank you, Scott, Amir, and Edward, and all our presenters. This now concludes Session 3, Performance Analysis with RETScreen Expert. Thanks for watching.